Okay, we finished up talking about probability, and now we're going to look at probability distributions. We will look at discrete and continuous, but this chapter is only discrete probability distributions, where we're interested in some random variable, the probability we flip a coin 10 times and we get 5 heads. So x equals 5 would be my random variable. So that's my what I'm trying to actually find. As I mentioned, you can have a discrete or a continuous. Discrete, you can count number of students in a class, number of cars on the highway. Continuous, I always think of more things you measure, the size of the desk, the height of a person, gallons that you put in your tank, because you can't get an exact value. Time, right? Because you might say, well, you were 5 minutes late. No, you were 5 minutes, 4 seconds, 3 milliseconds, nanoseconds, right? You could go on forever and ever depending on your measurement tool. And so anything you measure, okay, is continuous. We're only going to, in this section, go through 2 different types of probability distributions. One is just the basic discrete probability distribution, where you're going to be given probabilities, okay, of each of the discrete random variables. Probabilities, once again, have to be between 0 and 1. When you add all the probabilities up, you should get 1. How do you find the mean? Well, this one you have to take the sum of each outcome, okay, so your random variable, and multiply it times the probability, and you add all those up. The variance is still how far away you are from the mean. So you take each value of your random variable minus the mean that you found here above, expected value, square it, multiply it by each probability, and add all of those up. Standard deviation, still same thing, the square root of the variance. All right, so you get some practice with those. Then the binomial is the only actual discrete probability distribution that we're going to study besides just a normal discrete. And this distribution has an experiment is repeated a fixed number of trials. Each trial is independent of others, meaning what you do in one trial is not going to affect the other. There's only 2 possible outcomes, a success or a failure. I think right away of coin flipping, only 2 outcomes, right? Now, don't let the word success and failure throw you, because you might have something, what's the probability you're in a car accident and you die? Well, if that's what you're interested in, that's a success. I know it sounds kind of morbid, right? But what you're interested in, the probability you are in a car wreck and that you die, okay, is going to be the success. So be careful when you read these problems. The probability of success is the same for each trial, like flipping a coin. Once again, the probability stays the same. X, the number of successes you're interested in, and then N is the number of trials, number of times the trial is repeated. So you just repeat a test over and over and over. This is the formula. You're going to see that there are some shortcuts of doing this. This piece should look familiar. That's from the last section, combinations. We just changed the R to an X. So the number of ways something can occur times the probability of success, P, probability of success, raised to the number of successes, see up here, number of successes, times Q, which is the probability of failure. So that would be 1 minus the probability of success, and then raised to the number of failures, which would be the total number of trials, minus the number of successes. All right, so we'll have some examples of doing this manually so you can see the formula, but then you're definitely going to want to use technology. How do you find the mean, the variance, the standard deviation of a binomial distribution? The mean, just the number of trials times the probability of success, P. Variance, N times P times Q. And then, of course, the standard deviation, you square root that value. All right, so let's have a good chapter of discrete probability distributions, and then you'll see we'll move on to continuous.